Good morning, everyone, and thanks for being here at 8:30 in the morning on the last day of a long conference. I'm Rachel Franklin. I'm the incoming executive director of the Center for Geographic Analysis at Harvard University. I was at Newcastle before, so I don't know, some of you will have known me wearing lots of other hats because I've been lots of other places. But I'm delighted to moderate this panel this morning on digital twins. And what we're going to do is have a series of short presentations, and then we'll have some time for questions and discussion, which is often the most exciting part of a panel. So make sure you're gathering those questions. And I think with that, I'm just going to get us started so that we use every precious minute of our session time. And so our first panelist is going to be Chao-Wei Yang.
Thank you, Rachel. We organize this session to capture the digital twins for geographers because it's kind of new to the geography domain. So we want to put up some basic concepts to make sure that we're talking about the same thing here. So I'll spend maybe 5 minutes about the basic concepts. I want to use one of the examples we did back for rapid response to COVID-19. At that time, probably we can still remember we are locked down and our campus was not open. We stay at home. That's not healthy, both physically and psychologically. So we have to open the campus. But how many students and faculty members can we bring back to campus? That's a dilemma for the university admins. So what we did is that we take the George Mason physical campus and build a digital replica of the physical campus. Like you see here on the left side, it's the campus. On the right side is the digital replica we build. Based on that environment, we put agents on campus. Each agent represents one person. So we release the agents by different numbers. For example, if we release 5,000, which means we bring back 5,000 people, and they live on campus, have their daily activities, go to classroom, go to cafeteria, and stay in the dorm. And based on that and the interactions among each other, and we release the initial number of infected cases on campus. So we take a look, see how many people will be infected, like in 1 week, how many people will be infected, 1 month, how many will be infected. And based on that simulation, we found that if we don't do any control, no policy intervention, in about 1 or 2 weeks, everybody will be infected if we put 5,000 people there. But if we mandatory mask, the number of infected person will be going down. And if we use viral test, that will also be going down. And if we use all these policies in combined, that problem will be under control and meets the requirement of the university admin. So we give this kind of what if testing results to that means, and they can use this as a reference to make their decisions about how many students and faculty members we can bring back. And should we keep everybody with mask on and keep the social distance? So this kind of what if questions help us provide the solutions for campus reopening. And after that, we do the validation and verification against the real infected numbers. From the simulation, you can see here the red one is the biggest number possibly being infected, and the green line is the lowest, and the black line here is the real numbers. You can see that the black line is between the red and the green line, which means already very good. Of course, if we want to quantify this uncertainty from another perspective, it's probably like 20% or 30% accurate. But the number already matches really well here. And with this kind of feedback, we can use this to improve the simulation again and to forecast and to help us keep the campus safe. So from this system, we know that we first made a digital replica of the campus and also the people movement. So that is a digital replica which forms the initial setting of the digital twin. Another part is we do simulate and also predict how many people would be infected using the agent and also using public health models in this system. And also we optimize the solutions by asking what if? What if we apply different policies? What if we bring back 3,000 versus 5,000 versus 40,000? That's the total student number we have on campus. If we bring everyone back, of course, it's going to be probably everyone will be infected in a few days. So the results we use report to the university admin so they can help them make decisions. That's the last mile. We need to make sure our research gets to the decision makers' hands and they can make science-based decisions and help us save lives and control the spreading of the virus. And also in this process, the feedback, revise, evolve, and improve of the simulation system. And we can call it a digital twin system because what we're doing is a digital replica of the campus. And we do simulate and predict to see how many cases will be infected. And we also ask what if questions to have optimized solutions and also inform decision-making and then verify and form a closed loop to further improve the digital twin. So those are the basic concepts I want to put up here when you think about digital twins. These are some basic concepts. But for sure that everyone will have your own decision about digital twins. So if you have your own digital twin decisions, feel free. And we do want our panelists to provide your own definition of that. And also, we ask this list of questions to our panelists about what are some examples you have on digital twins, and what are the driving technologies for digital twins? What are the unique challenges, especially for geospatial or geographic digital twins in comparison to the engineering digital twins? In fact, in the engineering domain, digital twin is much more advanced than what we have in geography. So what's a unique challenge for us? And how AI contributes? We heard a lot about AI in this conference. So how that contributes to and drives the evolution of digital twins and how to ensure the trustability of digital twin, and how could geographers, us, contribute to and also leverage digital twin to advance our domain. And then what are the educational challenge and opportunities? So I will leave that here and we'll hear more from our other panelists. Thank you.
Good morning. I'm Xinye Ye from Texas A&M, and I recently I joined the National Academy's Committee on Digital Twin. So I was asked by Phil to give some introduction about our conclusions of the reports. So today I will share our two reports. You can scan the code. One of them is a general foundational research gaps and the future direction of digital twin report. The other is about how to use digital twins for the atmospheric and climate sciences. That's the most relevant digital twin report relevant to geography. So in our report, we kind of make definitions of digital twin, and we also provide quite a few practical kind of case studies and point out the future direction. So this is our kind of committee members. I'm the only geographer in this committee. So about digital twin again, and I think there's many kind of definitions. What we really want to emphasize is real-time bi-directional interaction between the virtual and the physical. At the same time, I'm very happy they emphasize social system also the part of the digital twin. Otherwise, most of the digital twin definition is very much engineering based. So the digital twin is more than just a simulation and modeling. For that is we are not only look at the two-way direction between physical and virtual. We are also considering how human plays a role inside of the interaction. We come up with quite a few examples. This is provided by some medical researchers in the team about how the cancer patient they utilize the digital twin to connect human body and the virtual representation, and for diagnosis and the monitoring of the human health. And this one is they use a kind of hurricane prediction example. The physical counterpart is a hurricane hunter aircraft to gathering data in the real-time storm. So the data you get from real-time sent back to the prediction center, then this guide this kind of physical counterpart to move in the storm to correct the data for further verification. And there's always curiosity about from the public is how digital twin will be used. At this moment, it very much outweighs the evidence base of success. So this report also provides some kind of recommendation. The first one is the verification, validation, and uncertainty of quantification. And for that is that we need to verify that model is implemented as we want, and the results should be to verified by the reality. And we also need to consider we have all kinds of uncertainty will propagate in the digital twin. So it will make bring up the issues how the digital twin is trustworthy. And we need many algorithm mechanism to provide digital twin researchers with enough computational resources. And we also need to focus on the many research needs, right? From how we virtually represent and how to get the data from the physical counterpart, and as for the two-way interaction. And last but not least is like we treat the human digital interaction is almost like the recent research on human computer interaction. And after the report released, we come up another big kind of workshop. We also invite Dr. Child for that, is for opportunities and challenges for digital twin in atmospheric and climate sciences. And for this one, is really we have quite a few experts question the use of digital twin because the Earth is too complex, and how you can use digital twin to really replicate that. So in this report, if you go to check that, there's a big portion of this report is go to review the climate modeling and the challenges of climate modeling. And we also touch some things about the DESTIN is a kind of the initiative by Europe. It's still ongoing. The large investments in Europe to develop a kind of digital twin Earth to predict the climate change. And for this one, so the big challenge is the scale system for digital twin, right? So there's a lot of needs of cloud resources, and also the utilize of GPUs, and we have quite a few panelists come up with ideas of how to utilize climate change digital twin. Certainly, the first is about real-time urban energy optimization, right? Then we also talk about how to enhance the climate models with AI-driven digital twins. So this is a big diagram about how the climate models have changed over years and become increasingly integrated and need lots of kind of how to connect model to model across resolution, scales, and different knowledge domains. And we also argue is we cannot build a digital twin for all. We need a digital twin have a specific research question to address. So it will make our verification more possible, right? So certainly we would also say is that for the digital twin technology will really help us to enhance climate models for previously cannot be possible. And there's many like challenges and opportunities. Certainly is how we see our digital twin is accurate enough for to replicate the Earth, and there's many uncertainties and credibilities, and where the model from, or what's the models the algorithm uncertainty, data uncertainty, and even how human interaction with the digital twin will also bring the further uncertainty. So the still quite a few scientists still question if we spend so many efforts in digital twin, so we cannot easily identify the complexity, right? So there's we need a further clear model purposes. So again, towards the end of the report, you will see quite a few writing about the transparency, societal benefits, and equity of using the digital twin. Because on the Earth, there's a data is overrepresented in one place than other place, and for people who understand the digital twin, there's a big gap of their knowledge, and as well as digital twin might be repurposed. Okay, thank you.
Yeah, to be as close as possible to this. I got it. Okay, good morning, everyone, and thank you for joining our sessions. I had a presentation about digital twins and human mobility till around 10 p.m. last night. Phil sent us the list of 8 questions, and we decided with the help of my students to make a little bit change to the presentation till midnight, so we can cover as much as possible that, the question Phil mentioned. So what you watch here is a footage of nuisance flooding happened last year in Philadelphia in one of the neighborhood, Germantown. So how many of you familiar with nuisance flooding or urban flooding? So a few. So nuisance flooding or urban flooding happening more frequently, less severe than coastal flood that we know, but it has a significant on transportation system and human mobility. So it's completely different from coastal flood, less severe, but more frequent. And with the increase in that, the rainfall, we expect that, we project that there would be an increase that, in urban flooding, which kind of completely that, disrupt the transportation system. So, and it happens that, to impact on human mobility because people need that, to change routes. People need that, to cancel their trips. People that, it impacts on the travel time, and that travel time that, impacts on the whole system. And here just that, an importance of digital twins for us to understand that, how we can use these virtual accurate systems of transportation to understand that, the human behavior. So it might seem that, a little bit simplistic at first to say that, okay, if flood happens, so then one or two routes would be closed and people are going to use other routes. But it's not that simple because we are dealing with the complex spatiotemporal systems of traffic flow and human behavior. So I give you an example here. So we have a simple 4 nodes, 4 links transportation system here with just one OD pair. So we have 2 routes. So route 1, 2, so that's the first route going from O to D, and we have another route. So 2 routes available. So if flood happens, and let's say that, street number 1 is closed or shut down. So what happens? People are going to use route number 2. So they're going to use link 3 and 4 to get from O to D. So that's simple. If some other routes close, so people that, going to switch and again use the alternative routes. If we make a system that, a little more complicated and add another line, so we have, again, one route of 1, 2, and one route of that, 5, and one route that uses link 3 and 4. And if any of them close, so people that, we can say, okay, people are going to use alternative routes. And that's simple. It's still that, I have a simple OD pair and people are going to use that, alternative available routes. But transportation network is more complicated than that. And then we have that, expanded network. And if a link here closed due to flood, then it's not that easy to understand that, what happens. And I'm giving you just that, an example of one origin destination pair, while in reality, we are dealing with multiple origin destinations. So having multiple origin destination here, then it's not that easy to understand what's going on. So if that link happens, and in this case, I'm just removing link number 7, but what if that, other links remove? How travel changes, how transportation rerouting happen, but also in reality, we are dealing not just with the routes with car, we are dealing with multimodal system where we are dealing with the transportation network for roads, public transit, metro system, bicyclists, and pedestrians. So this makes that, understanding that, how rerouting impacted, how travel behavior impacted, how trip cancellation impacted that, more complex. So here, almost a year ago, we started that, looking at this problem and to understand how nuisance or urban flood impact human mobility of people. So we put together an interdisciplinary team of researchers from geographers, engineers, social scientists, and urban planners to understand that, the spatiotemporal impact of flooding. So we are installing that, sensors and understand that, how flooding happens in 3 neighborhoods in Philadelphia, and then understand that, how this flood impacts the transportation decisions and travel behavior. And at the end that, we wanted that, to provide a digital twin system for our communities in a what if scenario that, if flood happens here based on the infrastructure they have, what happens that, to the travel behavior and decision-making of people. So we selected 3 neighborhoods, which historically they receive significant amount of urban flood. And so Germantown is the one that, you watch the video about it to see that, how it gets flooded. And we try that, again, to understand and give that, provide this digital twins that, that if this route is clogged or rain happens here, how different users that, react to that situation. So the different layers from geography that we need, so we need layers of the transportation network and systems that includes that, public transit, that includes our routes. We need that, green infrastructure that, reduces the vulnerability of communities to flood. And then that, we need some transportation information. So we need historical data of transportation. We need travel decisions. We need traffic systems. And then that, we need to design some agents that, to see how they're gonna move when under these what if scenarios that, things happen. So this was just one example of how we can use digital twins in understanding travel behavior of people. This field is growing, so just that, a simple search in Web of Science with different keywords alongside digital twins, you see that, the field kind of passed its birth stage, and it's in the growing stage, and we have almost at 300 or more than 300 papers right now with the keywords of digital twins, human mobility, travel behavior, and transport behavior. So I just want at the end acknowledge National Science Foundation for funding this research, and my students for helping me to put this presentation last minute together. Thank you so much.
We have Shenlong.
Yeah, doing good. Very good. Already, let me see. Oop. I'm finding the okay point. Great. It's good. It's good. All right. Good morning, everyone. Thank you for joining us in the early morning, as Rachel just mentioned. So I'm generally from Penn State. All right. So the topic I'm talking about today is autonomous GIS for digital twins. I only have 8 minutes. I know I'm having my timer here, try to make it on time. And this is the third time I'm talking about the topic of autonomous GIS today. So we know that for the important things, we need to say it 3 times, right? So I think this is an important topic for us to talk about here. So artificial intelligence in GIS science, that's a topic that you see a lot of sessions that we have been discussing in the AG. We call it geospatial AI, or AI for GIS, or AI for geography. But to me, I think it can be categorized into 3 categories in applying the AI or using AI in GIS. And the first one, we use AI as information extractor. For example, we can extract the water depths from the flood photos and extract the suicide tweets from a large amount of social media posts, or extract the sidewalk length or network from the street view imagery. So this is the information extractor, which we take a lot of data as input, and then with output will be the information that we need, extract useful information. The second part category is AI as spatial models. So we all know spatial models can do all kinds of stuff like air quality modeling, prediction, weather forecasting, right? And also wildfire risk modeling, estimation or modeling, damage estimation after earthquake. So those are the spatial models. We can do this modeling using traditional classification, traditional AI algorithm, but with deep learning, with generative AI, we can even do better or become more powerful. The third part, I really want to emphasize today here is the generative AI, which is, popular. We now everyone know that from the ChatGPT, right? In the late 2022, which make me so excited. And then we now started to research in a total new direction for us, I think. So the generative AI for me and for my team here, I think, we have 3 of my students here. It brings a very unique opportunity for GI science innovation. And so why? Because we can use the generative AI as a reasoning core, as a brain to develop the agent. So the agent I'm talking about here is a little bit different from the agent Dr. Yang mentioned before, like agent-based modeling, but here the agent more like a human. You can think of that human to do the task on behalf of you. So you can think about the agent. We can have a spatial analysis agent, for example, and cartography agent, data discovery, and a retrieval agent, which is all those are very important for digital twin development or application. And those are definitely will be very useful techniques if we can make it happen to be used in digital twins. And so the autonomous GIS here in the title, and we have definition here. 2 years ago, we have published a paper in the IADE. So the paper has quickly become a very popular paper and the most downloaded, and also the earliest and most cited paper in this domain, in this area. So we define autonomous GIS as AI-powered GIS that leverage, for example, generative AI, or in the future, near future, maybe, or in the long future, we don't know, the artificial general intelligence, or AGI. Some people debate that, oh, it will never come. But I think
for me and for some other people, I see it's already very close. But anyway, the ability to understand the natural language, the reasoning coding to address spatial problem in an authentic way, which is by doing spatial data collection, analysis, and modeling, and finally visualization. So some key vision about autonomous GIS here, and it is an emerging paradigm that I think, we think, by integrating AI or generative AI, specifically, or AGI in the future maybe, and with GIS, where it is not just another new tool that we develop with AI, but it's become an artificial geospatial analyst or GIS analyst here, that it knows how to use the tools. I think that's the key here, how to use the GIS tools, how to use the GIS models, or all this data that we have collected so far, produced, to solve the spatial problem in an automatic way. And the tools, we have so many GIS tools already developed in ArcGIS, QGIS. We can develop new tools using the API. We have so many APIs available, right? Python API, C++, so many API, SDKs, and databases. And spatial model, we have so many spatial models out there already, spatial learning algorithms, classifications, regressions, and deep learning model, for example, many of them. And even the Geo foundation model can be used as a specialized model to produce the required output, like prediction of the weather, for example. And it aims to make the spatial analysis of geospatial technology more accessible to a wider audience. And also, it expects not only for technology advancement, it also expects to further promote innovation in GIS science by through the large-scale automation. I think that's also key here. Large-scale automation can bring innovation because our human, we have limited time, but for the machines, they can do this 24/7. If they can do the modeling automatically. So how to achieve this? So we envision that it should be designed as a programming and a data-centric framework to automate coding, which is still using the existing framework that we hear, like tools, API, to address geospatial problem through by planning, implementing, and executing geoprocessing workflow. Yeah. So geoprocessing workflow, we know that it's the key. I think it's the key element or component in spatial analysis. All the spatial problem can convert to a workflow that with steps, operations, and data connect together, right? So we expect it can do this automatically. And finally, it needs to be implemented, for example, as a virus of different GIS agent, called GIS agent, that can work individually or collaboratively for a large complex problem. So this being said, a key ability for the GIS agent is to learn, to self-learn and self-improve, learn from document, for example, for the domain knowledge. We already have many textbooks, right? The ChatGPT already knows some of that, but it's very limited. Learn from experiences by doing the real work, help you when they help you do the work and they learn from there. And also most important, learn from the simulation when using the reinforced learning, RL, with human input. So simulation is really powerful, and Dr. mentioned about that. So we can simulate thousands of agents, for example, to learn from different scenarios, finally to optimize that solution. One quick example here. This is the input for a prototype, autonomous GIS system that I asked it to draw a map to show the death rate of COVID-19 among the contiguous US counties, and using data that I provided here. And I asked him to just create a map for me, and also draw a scatter plot to show the correlation between those death rate and also the senior resident rate, which you look at the age and the death rate of the COVID-19. So I want these two output based on just my requirement. And also I gave you the data here. So you can see I also provide some more requirement for the data, but now this is 2 years ago, developed by my student Huan Ying here. And now we already have added a data understanding module, which you don't have to specifically provide these details. The AI will look at what data inside and figure out the best field to use here, the best column or variable to use. So this is the result. First, produce a workflow here, and then produce the code, which is implementation of this workflow, and then produce the result map and the scatter plot. So with by running this automatically, autonomously, which you just need to input the questions. I have a video, I cannot show that due to time limit. You can search autonomous GIS in YouTube. You'll be able to find all this demonstration. We have many other demonstrations there. And finally, I think we have some papers if you are interested. Besides this definition paper, we have some other study like, GS Copilot, which is developed by Tammy Toppy, one of my students here, and also data discovery agent that we envisioned, and also some this agent for the transportation planning purpose. We did evaluation work there. So finally, I have some questions right here. I'm not sure I have time to talk about that so quickly. So I think that it had potential to make digital twins function at scale, right? You can manage, think about it, managed, operated by various autonomous AI agent with human oversight. It can shift the digital twins from this rule-based automation, which traditional automation, to this autonomous reasoning, which is it can adapt for the environmental change, which is very complex system for digital twin. That's very important. Okay, and I'm going to just spend 1 more minute, and then I will talk less when we do the panelist. And then GS data retrieval agent for automated data, integration, collection. I think this is also a key component for digital twin to answer Dr. Yang's question here. And so as we know, the digital from destination. So I think autonomous modeling and spatial analysis capability will play a key role, very important role for this region here, for this ask what if question, because we can do simulations in a very efficient way. So I have an example here. One example, for example, many or several GIS agents can work together to simulate or model outcome of route expansion scenarios with hundreds of configurations at the same time, considering different factors, and finally recommend the optimal configuration. So this can be done in the simulation, or when we have at least when we have this, we can also quickly pick up the best recommendation for the human. And you can also do the monitoring recommendation by this agent for emergency response, and also that's also in the question. We can identify the safe route, evacuation route based on current flood levels and route conditions if we can do this simulation or autonomous modeling quickly. I think finally, the digital twin provide a perfect platform for the autonomous GIS vision here to do the self-learn, self-improve, because we already have a digital replica that we can simulate. And then the simulation is key for autonomous GIS, as I mentioned here, to improve itself in the long term. So with all this being said, maybe we can come up with another term, agentic digital twin, which is run by this autonomous agents with AI. But anyway, yeah, thank you.
Well, today, my name is Chun Huang. I'm from Department of Geography at the University of Wisconsin-Madison. So I'm so glad to be here, share some of my research and thoughts on digital twin. In particular, I would like to share the 3 digital twin examples I have been working, as well as one enabling technology, Geol foundational model. So first, the example is digital twin for wildfire. So basically here I incorporate 4 modeling components from active fire detection, spread modeling, control, and impact assessment. For the active fire detection and impact assessment, mostly from the Earth satellite observation, we detect the fire fronts, active fire location, as well as burned severity locations. And typically for the spread modeling, it's much more complex. In addition to satellite image, we also leverage spatial data sets such as capture the weather, topography, field information to identify where is the next location of those fire front. For the control, basically it depends on the prediction of our spread model. We determine what's the active fire location we put our effort on, consider different information as well. For example, population, exposure, physical infrastructure. So any action we take at here, decide where to control the fire, it will impact the spreading of the fire, as well as the corresponding impact to the air, to the environment, as well to our population. So basically, an effective digital system for wildfire should all consider all those dynamics among human environment as well as wildfire. Here, let me quickly share some of the work we have done in those areas. First is active fire detection based on multi-source satellite data fusion. So basically, this is motivated by that current active fire products are limited by course, spatial or temporal resolution. So basically, right now, there are two widely used active fire products by NOAA and NASA. For the NOAA, it largely leverages GOES satellite. It can provide a quick Earth observation, 5 minutes, we have one product. However, the major issue is that it only provides 2 kilometer resolution, often resulting in false alarm, overestimate or underestimate of small fires. For the NASA product, it empowers fire information for resource management system, utilize views and models. It enhanced the resolution to 375 meters, but the major issue is that one day it only have 2 observations. And so my research is how can we incorporate those low spatial and temporal, but we can generate high spatial and temporal active fire product. We have developed different models from the auto-encoder to diffusion as well as generative adversive network to enhance, give the GOES input, we can produce various level spatial resolution. The second is fire spread modeling. So this is, I would consider as time series modeling and forecasting problem. Give historical active fire location, we need to identify what the fire front will be at the next hour, 2 hour, 1 day. So basically, we have incorporated the convolution neural network to capture spatial temporal dependence plus LSTM model for dynamic modeling. Right now, we are working on the graph neural network incorporate with the LSTM for better enhanced spatial temporal modeling. Next, we also do a series of model for impact assessment. For example, one of the work we developed is by temporal unit with attention mechanism and a tailored loss function that can handle 3 major challenges in the burned area and or burned scar mapping, including an imbalanced training sample, which is dominated by unburned sample, and the boundary area with a mix of burned and unburned sample. And also our model trained in the Chico, California wildfire and test on a variety of locations, including Australia, Spain, Indonesia, and Kenya. Our results indicate that our model can achieve the best performance and enhance the baseline about 11% of improvement. Next, we also, in addition to identify the burnt area, but we classify the burnt area into different categories, including low burnt, moderate, and severely burnt category. And our model incorporates pre and post as well as normalize burn ratio to enhance the detection. Compared to a state-of-the-art classification model, our model can achieve more than 84% of evaluation score across different performance assessment. So the second digital twin, actually, I have been working on by collaborating with the civil engineers, my colleagues in the campus, as well as the University of Texas, Arlington. So basically, the idea is that we incorporate the satellite Earth observation, as well as AI machine learning, physical process-based model. We can replicate the weather, water, hydrology, reservoir operations. We can provide the forecasting of inflow and outflow as well as reservoir water level in future as well. And we can perform what if scenario analysis. For example, what if there is 10, 50 and 100 year of flooding droughting event, what we will do, what the release schedule should be, and provide the decision making. So this is also built on our existing work on global flooding mapping. So we have developed a series of models from supervisor learning to self-supervised learning, as well as to weekly supervised learning. And our model, again, tests on the developer based on the United States data set and the test on global location, including China, Australia as well as German. So basically our model indicate that we can achieve more than 90% of accuracy for the global location. In addition to remote sensing, we also largely utilize the photo image capture from the social media news data as for the depth assessment as well as the image damage assessment. So basically, in addition to image, we also incorporate text information for established situation awareness as well as damage for assessment. For example, from massive social media data, we extract disaster relevant information and then further classify it into different categories like infrastructure, utility damage, volunteer donation, affected individual. And for the damage relevant information, we then further classify them into different damage level. Here is another example we have been working is modeling the entire watershed and the river basin into neural network graph. And basically, based on different graph neural network-based model, we can perform short-term, mid-term, and long-term forecasting for the stream flow as well as flood. So last addition I want to share, which is also an exciting work with the agronomists, the breeders, as well as local farmers to develop an accessible digital twin to support sustainable agriculture. So basically, we incorporate a variety of data sets as well, including multispectral, hyperspectral image collected by the UAV, climate, soil, geographic information, and to perform a phenotyping task, including identify, predict the yield as well as the nitrogen. So we can provide the recommendation what is the optimal fertilizer as well water usage to optimize the benefit. Finally, I want to mention that based on all the application I have developed so far, one of the major scenario I have observed is that all the model we should incorporate different type of data sets. So that's driven me to develop a Geol AI foundational model that can incorporate different data sets and train in a self-supervised learning and fine-tune for different application. Well, take this moment, I will thank my students, collaborator, and sponsor. Thank you for everyone.
First of all, I would like to thank Phil and Rachel for organizing this very interesting panel discussion. So the topic related to ethics, trust, and uncertainty already being touched by the previous speakers. So I will try to give you a high-level summary in the next 7 or 8 minutes, and then I guess we can reserve some time to hear from all of you to answer any questions, so that we can have a conversation about all these latest exciting new development. So without repeating too much, everybody already all the topics already covered. So essentially, for digital twin technologies, we have 3 components. So the real world entity or process and the virtual representation, and the data that connects the two. So and also there are different kinds of digital types of digital twins out there. But one of the most important new development in recent years is really a convergence of a variety of technologies, like the Internet of Things, a data connector in terms of analytics, converging with AI, machine learning, and also digital twin is rapidly converging with the simulation technologies, of course, also connected to the metaverse, augmented reality, of course, the data and the system integration. So converging technology is really, convergence is really the core concept for us these days to understand digital twin technology, and also the GI science, the Geo AI, and then more broadly, because all these different pieces are really connecting. So for geographers and the GI scientists, I think the most exciting development is to try to develop a digital twin of the Earth, also in studying in the broader context of global climate change. But viewed from the ethical perspective, as you shall see, my argument has always been digital twin, and along with many other technologies, they are simultaneously both part of the solution and also part of the problem. So we have to think about all the environmental implication, energy consumption behind those emerging powerful technologies. So before I get to the main point these days, I guess we need some tech support from this guy. These days we cannot understand the technological world and also the political world without talking about Elon Musk. So my talk, the key point I'm here is apolitical. So let me make that a disclaimer because otherwise I can get myself into trouble. So I have been watching, the business empire of Elon Musk for quite some time. What is striking to me is like different from other billionaires like Bill Gates or Jeff Bezos. All of them are good excellent as an entrepreneur. But Jeff Bezos and the Bill Gates are focusing on one thing. But Elon Musk is very different in the sense, think about his early days in PayPal, and then he got into Tesla and Solar City, and he also had been working the Hyperloop, the new transportation system, through his Boring company. But if you holistically take a look at his business empire from Neuralink to OpenAI, all the way to Starlink and SpaceX, and now his ambition is to go to Mars to make humans a multi-planetary species. And also his business covers everything in between, including, of course, he's now control X, formerly known as Twitter. And also he has this powerful new AI tool, Grok, is a X AI tool. So in an interesting sense, his way of thinking is always very intriguing to me in terms of trying to understand how Elon Musk's mind works. So I hope you agree with me. His thinking actually is very geographical. So because he can think across domains, and also more impressively, he can think across a scale. From Neuralink all the way to Starlink and everything in between. So in that sense, I do like it or not, I do think Elon Musk is in terms of his way of thinking is well aligned with the geographers and the GI scientists' way of thinking. So in one of his ways, this is he revealed how his mind works. He told this interviewer that he follows the first principle. He said, the first principle, the basic idea is looking at the world. You boil down things to the very most fundamental truth, and then reason from there. That's if he said if he can put pin down on one thing how his mind works, he thinks he follows his first principle. So now let's get back to the main topic today, following Elon Musk's first principle. When we are talking about ethics of digital twin, what we are talking about? I think at the fundamental level, we have to be mindful. We aim to try to do the right thing for the right reason. If you add to the specific spatial, temporal, and the human dimension, so the ethics of digital twin following Elon Musk's first principle will be, we aim to do the right thing for the right reasons, but also at the same right time, right space, right time with the right people. Sorry, I missed, there's a typo on the slide there. It should be at the right time and the right place with the right people. So when we are, in a nutshell, my key point is with all these converging technologies, we are entering into an uncertain future with digital twin technologies. And the digital twin technology cannot be trusted 100%. We can only partially trust what's going on. So that's my main point for today for discussion. So here's a breakdown in terms of the unresolved ethical issues related to social human dimension, especially privacy, data sharing, and the surveillance, and the emerging digital divide. There is also an economic dimension in terms of the emerging new economy. It has huge implications of the future of work, especially what it means to work when everything that we can do can be done by smart machines. So there inevitably there will be winners and losers. And I already hinted, behind this powerful technology, it consumes a vast amount of energy and material. So what are the environmental implications? That is why I don't believe digital twin is viewed from that angle is not just the solution. It is along with all the other AI quantum technologies. They are also part of the problem contributing to the rapidly evolving global climate change. Of course, when you move from the individual to institutional national level, there are always a security dimension and also political dimension in terms of misinformation. So understanding the ethics of digital twin, we have to break it down to individual, institutional, and the society level. So what do we go from here to? I have been working with my colleagues from across multiple disciplines in terms of developing a digital twin ethical framework. These are the sort of 6 dimensions. Developing new ethical principles and the values. It also engage, the discussion with the new legal regulatory framework, and also they develop a standard certification, also involving the public participation, provide oversight and monitoring, and last but not least, this is all the issues related to digital twin ethics transcend national borders, so we have to enhance international collaboration. So this is the sort of more the convergence framework that we have been thinking in terms of connecting all the dots. I don't have time to get into the details, but I would like to mention one thing I have been working on and off. So some of you may familiar with Alberto Eco's work. He has a fascinating book, collection of essays, How to Travel with Salmon. So in that little book, he has a short paper entitled On the Impossibility of Drawing a Map of the Empire on a Scale of 1 to 1. Actually, this is I say highly relevant to the ethic issues we are talking about, the digital twin. So on and off, I have been working on a paper tentatively entitled On the Impossibility of Developing Digital Twins to Simulate the Earth's dynamics. But I have not got it completed. So I would be, if you're interested in this topic, I would be happy to invite you to join me to work on this together. So with that, I will stop there I would be happy to answer any questions you may have.
Thank you so much, Dan. So I think if I could invite all the panelists to come to the front, we definitely have time for a few questions. And if you're all up here, it's easier for the audience to see you and hear you. All right, do we have questions? Yes. They may not be able to, but if you give me the question, I can repeat it back. Okay, so this is a question about skills that are needed in order to meet the challenges around, I think, GI science and digital twins. Thoughts?
Yeah, I can take it to my. Thank you for this question. Excellent question, because this is something, every time I give this presentation to the audience and always being asked about this question. And definitely there are some concerns about, job displacement, for example, and if this entry level spatial analysis can be done by a machine. And at least we already see that. And, we are working on some demos, and we also have a GIS Copilot for the QGIS, and shows that you can ask question by doing analysis. And also Esri, they are trying to show some demo to show that as a chat box to their ArcGIS. So I think those are very, very valid question, and it's serious question we need to consider about that. So my opinion is that, first for job part, I thought that it can be make some like entry spatial analyst, probably not that needed, but at the same time, it creates more kind of reward jobs at different kind of level types. And for student, I do see that you still need to learn this basic, GIS skills, this very important skill, spatial thinking skills. Our human have, spatial thinking, reasoning, and place-based thought, those kind of skills. And also, but the tool can help us to do this, tedious work sometimes, but still we need to have this creative thinking and skills to be better to use these tools. And I think, to get some training on AI and on how this works, get training on those, like, if we have a GIS Copilot in the future with very popular, and then probably it's good to learn how this works in the backend. So at the same time, and programming, I think is very important still. For me, I think programming is still important for all students to learn, to prepare for the future. That's just my 2 cents, right?
Okay, can I say something on this topic?
Yes, please.
Yeah, so this is an excellent question. So one thing I would like to mention that put on everybody's radar was recently at Virginia Tech, we invited the president of Northeastern University, Joseph Aoun. He's the author of the book entitled Robot Proof. So the subtitle of his book was on the future of higher education in the age of AI or smart machine or something like that. So the point he made, which is something I thought was really interesting. He thought, moving forward, higher education needed to restructure its curriculum around what he called humanics, not humanity, but humanics, which has 3 components. One is related to the technical AI, machine learning, and the coding, that kind of technical stuff. And then there should be the computer, the technology, more engineering. But thirdly, it is the field related more to the traditional humanity and the social science. He himself is a linguist. He published the book initially published in before the pandemic around 2016, but nobody paid attention. Now, starting about 2 years ago, with the explosive growth of LLM and all the generative AI stuff, he has become the best thought speaker. So I just want to put it on that book on your radar, because in that book he articulated a vision, for the entire higher education in terms of how we should restructure our curriculum and also train the next generation of leaders for both research and industry.
Thank you.
Yeah, I just want to quickly follow up on that. In fact, from a curriculum perspective, we're looking at that, how the AI has impacting the skills needed by our students, and also how the workforce has been changed. As Dan mentioned, a lot of program work, in fact, used to be done like by 10 people. They can now be done by 3 or 4. So how that kind of trend will impact the GIS domain, we're looking at that. And in our college, and part of the curriculum committee, looking at how to revise or adjust our curriculum for adopting AI and how that impacts our skill training for our students. So that's a very good point and question.
I also want to add something is I'm from Texas A&M, the urban planning. Teach GIS to urban planning students. Previously, we use the same like course materials as how I teach geography students. But nowadays, A&M urban planning already updated our curriculum is integrating urban studies and urban design, because previous design students really don't have too much exposure to the GIS kind of procedure. Now with the GIS become analysis become more automated, then it will become more and more realistic, is allowing those GIS students, geography students sit side by side with previously architecture design, urban design students. So we quickly turn the knowledge from you learn from pattern trends of the urban layouts into the design practice.
We have time, I think, for one more question at least. Yes, please. Okay, so the unique advantage of digital twins. Anyone?
Okay, I can start. So, I think one of the advantages from the point of disciplines that I'm coming from. So my background is in engineering, so also in planning, and I'm in geography right now. So, kind of say that have an interdisciplinary background. So, I think one of the most important advantages in comparison with many simulations we have done in the past for travel behavior, for transportation, is here we are looking at, the accurate representation of real world, where that, we can definitely see with 100% accuracy that what's going to happen under different situations. And it would be a really science-based community informed decision-making system, which going to help that, under future scenarios, what's going to happen. So we can prepare our communities for what's going to happen in the future. Something that, we are not looking at, some adding new tools to existing tools and kind of like fatty communities with tools that they have, but we are trying that, to bring existing tools and data together and put it that, in a representative box that everyone, specifically for decision makers, can use it. So I see that as a really unique advantage of that, digital twins, to bring all these together from different disciplines and to design a system accurately represents that, the physical twin in a virtual twin that can benefit that, everyone across the community.
Yeah, that's a very good question. In fact, that's what we want to answer in this panel is what's the unique contribution or challenges of digital twin to our domain, also maybe to others. As we put in the title and also in the abstract, digital twin is really the cutting edge paradigm or the latest paradigm of digital transformation. So the leverage almost everything on digitization or digital transformation in the past. But this is really the time that could reach to the decision makers. As geographers, well, we were always questioned, what does it mean for your research? What do you help? And what's the impact? So this is a time with the digital twin, we can fit that into the decision makers that could make the societal impact, could aid to the decision makers to do smarter decision and to integrate really our geographic research into the digital twin, so our research really counts. I think that's the most important to geographers.
I can just follow up. I think this is a very deep question and a very inspiring question here. So for me, I'm from my topic here, autonomous GIS, which is I think agent based or AI driven, those kind of spatial analysis or AI driven digital twin in the future, in the near future, you will see that. I think the key difference from what we are seeing now, we might be able to see that, all these components now being, sparsed in different places. Now they are able to be connected together by and operated or managed by a lot of virtual AI-driven agent. And then they can, as I said, they can do simulation. Like think about smart cities. We have all this problem like traffic and building new building, create a new building or schools and all this problem now. Now we need human involved, a lot of manual work still, and also a lot of resources we need, data integration. By that time, with the efficiency of the AI, which is they can work nonstop 24/7, we might be able to create better solutions, make better or more, much more efficient decision or recommendation to the human, to the manager or decision makers to definitely serve our life or better. And so I do see that can be a key changer, which is automation, to bring large scale automation and integration from all kinds of data, which is because digital twin is a complex system. And the other thing I'm seeing is autonomous modeling, which is I mentioned autonomous modeling, which is spatial modeling, spatial temporal modeling, or it can I hope that it can bring large scale innovation in our, for example, for geographer, GIS and research. Think now we are all doing research, right? Student, PhD student are doing research. You think about an idea, you come up with a hypothesis, you collect data, you spend like months, years of doing that for just one dissertation. And if we can have the agent like with trained domain knowledge of GIS, talk about GIS science, and then they can come up with hypotheses by reading papers, and then they can test this hypothesis by using simulation, using like iterative itself to become better, and then that can create to move forward with the scientific innovation or scientific advancement more, and which is also good for our society. And yeah, I think that might be change. And also in terms of jobs, I think maybe we all get very high paid. We don't have to work like so many hours a day, and we all live a good life with all this AI working for us. Yeah, but there are those challenges, of course, to consider like privacy, ethical issue. But yeah, that's why we are here to discuss this. Thank you.
Okay, we've reached the end of our time. Last comments. If you two want to make.
Yeah, so I can have a quick comment. Thank you. So I think the digital twin will fundamentally change the way how we design. E&M, the College of Architecture, is the largest college of architecture in the nation. So we are promoting this idea is how the digital twin and AI totally reshape the design. Because if you think about design from interior design, architecture design, construction science, urban design, regional development, all these involve many different conflicting interests and the groups. And previously, people who have the money to invest, but they don't have expertise to really draw the map, understand the data patterns, and keep back and forth arguing the points. But now is with the assistance of digital twin and AI, we can quickly bring everyone onto the table and equip the people who only use natural language. You can also come up with some design, and if you have some feedback, can immediately go back to the professional designers. So it's an exciting time. It's allowing us to connect the doors from indoors to outdoors. Yes.
Let me quickly respond from the natural hazard perspective. Yesterday, I was sitting in the panel of community resilience, got a question about, we have so many modeling for rapidly detect the disaster and predict the disaster. However, still we have damage. Yeah. And so basically, how can we really translate the research to the real world application to support the operational management as well as to inform this policy making? I think the digital twin may be the solution to close the last gap between the translation or between the research and the real world application. For example, if we have all those modeling capability of wildfire, we can predict where is the next fire spread. And we have the location of the personnel population and the infrastructure. And we have limited resource, and then we will we will simulate where we should put the effort on the location that have minimized the damage to our society. So basically, I think that's the digital twin has that power to do the what if scenario analysis and make the most informative decision for us. Yeah.
That's an excellent way to end. I'd like to thank all of the panelists and thank you, the audience.